Hello everyone, welcome to today's class on vector algebra. So today we would find how do we determine the magnitude of C given the fact that we know the magnitude of its components. So one property of vectors is that vectors can be shifted. Vectors can be shifted from one side to another. So far you do not change the direction or its magnitude, the vector is still the same. For example, consider this vector B. I can just shift it here. So I want us to see something. If I shift this vector here, let's shift it properly. So now I've shifted this vector here. By shifting this vector here, we can see something. We can see that we have a right angle triangle, and from Pythagorean theorem, where we have the base of the triangle, its length is the magnitude of vector A, you can see, and then the this height, its magnitude is the magnitude of B, because we didn't change anything, and the hypotenuse is what is equals to C. So therefore we can obtain the value of C using the Pythagorean theorem. And obtain the value of C using the Pythagorean theorem. C squared, if you remember the Pythagorean theorem, is equals to A squared plus B squared. So therefore we can say that C squared is equals to A is what? 3 units, 1, 2, 3. A is equals to 3 squared plus, what's the magnitude of B? The magnitude of B is 1, 2, 3, 4, 4 units, plus 4 squared. So we can see that C squared is equals to 9 plus 16. C squared is equals to 25. Then we can take the square root of both sides. Square root of C squared is equals to the square root of 25. Therefore, we can say that C is equals to what? Plus or minus 5, right? But since we cannot have a negative magnitude, because magnitude just represents length, we can say C is equals to 5. And that's how we get the magnitude of what? The magnitude of C. What did we do? First of all, we shifted vector B to this side. Then we notice it formed a right angle triangle. Then we use the Pythagorean theorem to obtain what? To obtain the magnitude of C. So thank you very much. See you guys in the next video.